You all my lecture series of automata theory and compiler design. In today's video, we are going to see about one case study on finite state automata. Already you know that what is a finite state automata. It contains the 5 tuples. You have the start symbol and the start states and the set of final states and set of transitions and set of input symbols, and also that how the transition is done. So the starting state and set of input symbols and set of final states and transitions. So these are all the finite state automata. So the automata is nothing but it is a collection of it is a finite automata means the states should be the finite and it should do some task from input to output. So the finite state automata, it is a two types. One is a non-deterministic finite state automata, other one is a deterministic finite state automata. So in the automata, it consists of a transition diagram. It consists of states and transitions. For example, considered using the finite state automata, this is a problem statement. Can you find out how to design a finite automata for checking if the given number is even or not? Suppose they are given some binary number. That number could be that even or not. That checking we have to design a finite automata for checking the given number is a even or not. So how to do means first we have to design. First we have to find the solution and logic of how what is the even and odd number. You should know the logic behind this thing. First we have to do the logic, and the second step is design an automata. Finally simulate the automata with the given input symbols. First, what is an logic begin is suppose the number last digit end with either 0 or 1. So the question is we are here going to design an automata if the given binary number is even or not. So what is a binary number? It is a combination of ones and zeros. So the last digit, the leftmost digit is either 0 means it is an even number, whether it is a last digit is 1 is it is an odd number. This is the logic behind the given number is a even or not. So the number end with 0, it is an even number. The number end with the 1, it is a odd number. Okay, so next is we have to designing the automata. Before designing the automata, we have to find out what are all the languages we can derive from that binary number. So languages are, for example, even number means 0, 0 0. So all the numbers end with 0. So the q not all the strings ending with 0. In the q1 means all the strings ending with 1. So you have to design like that. Okay, you have two states. The basic symbol is 0. If it is 0, it is a even number. If it is 1, it is a odd number. So the q not all the strings end with a 0 and q1 all the strings end with 1. So we have a two states, q not and q1. So this is the design. First, for a single input symbol, draw only one q not. The self loop we are containing. Suppose single 0 means there is a self loop of 0 transition to the q not itself. Suppose 0 1 0 means first we have to read 0, and from q0 to q1 we are going to do the transition of 1. After q1 again you have a 0 transition, and that could be end with the q0. So 0 1 0 means what? So what is the simulation states means q0 to q1, then q1 to q0. So this is the simulation state. Suppose our input symbol is 0 1 1 means 0. After reading 0 from the state q0, when you read 1 it goes to the state q1. So again 1 means you have a self loop on q1. Okay, so the q in the starting itself we have to decide the q0 state ending with 0, in q1 state ending with 1. Okay, so this is the diagram for accepting any binary number of a even any binary number, whether it is an odd or even. So the simulation is, suppose I have a string 1010 means, so what is the state transition? Q naught இருந்து I am going to read 1 means it goes to the state Q1. Next input is Q0, so Q1 to 0 again Q0. Next Q0 to Q1, when you read 1, then again Q1 to Q0 we end with 0, so that is an accept state. So here there is a two states here. That accept state is Q0, so that state is end with the 0 transition. I hope you will understand how to design binary number, binary even number. So the given automata, it checks whether the given number is even or not. So for that transition, first thing we have to find the logic behind the what is a even number, binary even number. Next we have to designing. Finally we have to simulation. Thank you.